David Smith here with another flipped classroom math lesson. A few tips before we start. First, remember that you can speed up or slow down the playback if that helps you follow along. Second, you can turn the captions on and read my words on the screen. Third, you can pause the video at any time to catch up with your notes or write down questions for class. Did you hear the one about the robbery that was attempted at the supermarket just yesterday? Yeah, it was pretty cool. The clerk fought them off with a label gun. Now they're looking for a guy with a price on his head. Anyway, here's another video for you guys in Math 2. And yeah, it's casual day. I'm on my weekend and I just recalled that I needed to make this video for you guys, so I ran into the classroom and here I am. So let's take a look at that. On the planner, you'll see the page number for tonight's homework is a chi-square probability table. So I'm going to go over that on the board and then we're going to jump onto the computer and I'm going to walk you through the table that's actually in the book. Okay? So far, we've been calculating chi-square values, and you know that if that chi-square number is higher and higher and higher, the null hypothesis is less likely to be true. And so we've been able to compare chi-square values for different situations and be able to say like which coin is most likely a rigged coin, things like that. You're also starting to get a feeling for what constitutes a high chi-square number. And so we're going to take a look at that. You're going to get some very precise language and ways of evaluating your null hypothesis. So let's take a look at the table. So from your book, I copied the first two chunks on the board. It goes up quite a bit further, and we'll get there in just a sec. But you can see this part is your chi-square value. Okay, so there's a chi-square of 0, 0.2, 0.4, 0.6, 0.8, 1.0, and so on. So they're giving you certain chi-square values. And so part of what's complicated with this, if you get a chi-square that's like 4.5, how do you read the value off the other side? We'll get to that in a minute. So, if the chi-square is 0, actually let me back up just one sec. Before we do that, let's take a look at the second column. This is the probability that the null hypothesis is true. Okay, so let's take a look at that for a sec. Chi-square is 0. The probability that the null hypothesis is true is 1, or 100%. Okay? If you get a chi-square of 0.2, then the probability that your null hypothesis is true is 0.6547, or 65.47%. Remember, percents are written as decimals if they're actual numbers. If you want to turn the number into a percentage, you multiply by 100, which is the same as moving the decimal 2 places. Okay? So pause the video, think about this. What if my chi-square was 1.2? What's the probability that my null hypothesis is true? So what we do, we shoot down our chi-square table and bam, here's 1.2. So the probability that the null is true is just 0.2733 or 27.33%. Okay? So chi-square of 1.2, which doesn't seem too high, the null hypothesis only has a 27% chance of being true, which means that the hypothesis has roughly a 73% chance of being true. Okay, interesting. So if you got a chi-square of 1.2, it's more likely that your hypothesis is true than your null hypothesis. Okay, so let's take a look at how that might work. Let's do another one, okay? Let's put a bunch of chi-squares up here. Here's chi-square, and here's the probability. What if your chi-square was 0.6? What's the probability that the null is true? Does it belong here? Here's 0.6. Probability is 43.86%. Okay? Pretty straightforward. Reading the table is not too hard until I give you one like this. What if the chi-square is 0.9? Okay, let's look at our handy-dandy table. Let's see. 0.6, 0.8, 1.0. There's no 0.9 on my table. So here's how you do that. This is an estimate thing. Okay, so when I grade a test or a quiz, as long as you're close enough, you'll get full points. 0.9 is halfway between 0.8 and 1.0. So the probability is roughly halfway between 0.37 and 0.31. So I'm going to say that that's probably like 0.34. So 34%, roughly, okay? Not totally accurate, but good enough for our situation. Let's try another one. Let me give you another hard one. How about 1.3? Or the null, let me get it straight. The chi-square value is 1.3. What's the probability that the null hypothesis is true? Look at the table, see if you can come up with it. Same as what we did for 0.9. Okay, 1.3 is halfway between 1.2 and 1.4. So the probability that the null is true for a chi-square of 1.3 is going to be halfway between 0.27 and 0.23. So roughly 0.25 or 25%. And what you might do here is put an approximately. This little wavy line means about. That's the tilde on the keyboard. Okay? So 0.9, roughly 34% chance. 1.3, roughly a 25% chance. Let me make it a little harder. What if the chi-square was 1.45? Okay, so now it's getting a little bit more tricky. See if you can figure that one out. Okay, let's take a look at the table. 1.4, then I go to 1.6. Okay, 1.45 is 1/4 of the way from 1.4 to 1.6. So it's not half, it's just 1/4 of the way. So this is roughly going to be, like I have a chi-square of 23 and a chi-square of, or a probability of 23% and a probability of 20%. We're going to go 1/4 of the way. So this is probably going to be something like 22.5%. And I'm good enough with that. You could get really mathematical if you wanted to. You could take a look at the difference between the two, and then you could multiply that difference by 1/4, because we're 1/4 of the way between here and here. And you could be a little bit more exact if you wanted, but I think you could do these in your head. Just make sure that, see, this one is closer to 4 than 6. This chi-square of 1.45, it's closer to 4 than 6. So your probability needs to be closer to the probability connected to the 1.4 than to the 1.6. And indeed, that's what I've done. Okay, so I want to go over the same thing, but looking at our textbook, which will be your reference for evaluating your chi-square numbers. Before we start, just know that you've got to have a decent sample size to use this analysis. If your sample size is really small, like less than 5 or something like that, you really can't use chi-square. You just don't have enough data to do any kind of statistical analysis. And that makes sense. It's like if you flip a coin 5 times, do you really know much about that coin? Probably not. So remember, your sample size should be nice and big. Okay, so here is the table that's in our textbook. Should look pretty similar to what you saw me with on the board just a second ago. And here are our chi-square statistic. That's the column for that. And you can see then here's our probabilities that the null is true. And you notice that those probabilities are going down, down, down as your chi-square value goes up, up, up. Now take a look at the territory here. If you have a chi-square of 2, the probability that the null is true is only 15.73%. So that's a pretty low probability, okay? I would say with the null being only 15% true, that it's very likely that the hypothesis is true. Okay, so we're starting to use those qualifiers in terms of the likelihood that our hypothesis is true. If you have a chi-square of, let's say, 3.8, check this out. It's only a 5.13% that the null is true. That means it's just about a 95% chance that the hypothesis is true. Now, that's not something I'd bet $1 million on, because a 5% chance of losing $1 million is very significant when you talk about something like that. But I would also say it's very likely that the hypothesis is true. Now let's scroll down. We're getting into 4.8, only a 2.85% chance the null is true. But check this out. It goes on to the next page. And here, we're starting to get really tiny probabilities. Like, check this out. At 7.8, a chi-square of 7.8. And remember, we got some pretty big chi-squares when we were playing around with the calculation. But if you have a 7.8 chi-square, the probability that the null is true is 0.5%. Okay? That's 0.5%. That's a 1 in 200 chance that the null is true. So yes, it's possible, but not very likely. So you would say here that the hypothesis has a very high percent chance of being true. It's almost certainly true, but never say certain, okay? Because you just can't be sure. If you flip that coin 200 different times, if you do, not 200 times, but if you did 200 trials, say of 50 flips each time, one of those trials could get you a chi-square of 7.8, but not very likely, okay? So if you get a chi-square of 8 or more, it's less than 0.5% chance that the null is true. So you're in the realm of being very, very close to certainty. Okay, so that gives you a feel for how to use the probability table. Let me summarize. What you do is you calculate your chi-square for your situation, and you look that number up in your table, and the table will tell you the probability that the null is true. So if the null has a high probability of being true, that is, if you have a low chi-square value, then most likely the hypothesis is not true, that the null is true. And you remember what we're doing with this is we're trying to reject the null hypothesis, because then that tells us that something is weird. Now that you've finished the video, take a moment and jot down some notes or questions for our next class. Remember that you can also watch the video again if you want to increase your understanding. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.